Alright. Um, Today we're gonna be k-means clustering data. Uh, Sorry if I seem a little bit distracted. That's because I am. Um, a little bit because I'm to be honest, I'm playing a couple board games at the same time. So yeah, it makes sense. Yeah, so that's why I'm a little bit distracted. I hope it doesn't take away from the experience too much. Um, but yeah. Uh, Yeah, something though, I figured out how to sort of check my chat on stream. Uh, so that won't be a problem soon. So anytime someone chats, that won't happen anymore. Um, I don't think anyone will particularly be watching, to be honest, but yeah, it is what it is. Okay, yeah, so what are we doing? Yeah, okay, so just to sort of recap, we're like k-means clustering this data. Um, Honestly, it's been a second, but basically what we're doing is let's just run the code for a second. Try to see if there's a bug. Okay, yeah. So where's the problem prepend? Uh, Same row length. So the same row length, right? So dude, honestly, I need to like okay. So here, because if it's too small here, you can't see the debug information. But I don't want to make it too big to where you can't see this on the left side. I don't know. Maybe I'll get a second monitor or something, so it's just easier. Or I don't know. We'll figure something out. Uh, okay. So before we do this, let's just do quickly. Let's just print the row. Print row dot num columns. Wait, is there a shape attribute? Did we add a shape attribute? Check our code real quick. Yeah, self dot shape. So we can, instead of doing this whole sort of thing, we can just do print row dot shape, and then once we put the shape, we need to immediately break out of the loop. Just for some debugging purposes. So let's just quickly just boom. Yeah, so this will help us debug. Oh yeah, actually we didn't need that. Let's go back. Yeah. So it'll break out as soon as it runs one iteration, it should break out. So it's a list, right? The rows are lists. Um, what we can do here is we can make it a matrix real quickly. We can just do an interspersed matrix operation, and then we can get the shape of it. Um, hmm. The row is a float. Wait, so before we do it, let's just print the new clusters really quickly. Right, so we've created a new cluster. Yeah, so here, as you see here, right, cluster one is as below, cluster two is here, and cluster three is here. Right? And then cluster three is here. Um, and then what we're trying to do is we're basically trying to take each row in the new clusters, right? We're trying to iterate over. Oh, I know the problem. I know the problem. There's 30 here, isn't there? Or 1, 2, 3, 4, 5. I know the problem. See, when we do for I dot row in new clusters, it's gonna have the whole object here, this whole list of lists, and it's gonna have that be the thing. So what we need to do is for I dot row, and then we need to do for x in row, and then we should try x dot prepend I. Let's just try that, and let's just see if that works. Um, so clearly that, but Control Z, bro. Okay. I'm confused, to be honest. TBH. It's saying row is a float. How can it be a float? It's literally just, how can it be a float? That doesn't make sense. Like, what? How does that make sense? What? How does this make sense? How is row a float? Like, how could that make sense? Someone explain it to me. Or, well, obviously there's no one here to explain it to me, but, like, sorry, why does that make sense? Oh, bro. Row is just a list, so we need to do that. For int and list. inside our depend function, uh, so we're looking at the row, a certain row, right? And we're basically saying that the object, we're basically saying at that row it's equal to matrix.I plus self.matrix. So how does it work beforehand? Like how does that work? Uh, so basically saying the matrix of wait, why does that not raise an error when I'm doing it here? Uh, so now there's no error when I'm doing it here. We should probably just debug this to be honest. Hmm. Dude, this doesn't make sense at all. Like I think I'm just blundering into the darkness here. Yeah, exactly. Like look at this. What's this error here? This is in for this here. It's saying index out of range, so it's not able to initialize the matrix. Okay, okay, we need to take a second just to come back and just calm down for a bit. So until here, it's fine, right? We have the cluster, we have the new clusters, and we have them clustered. So now what are we trying to do, really? We need to just make sure we're updating properly and doing the right thing. Um, so we have the clusters, right? As we see, what we should be doing is we've already reassigned the clusters, and we just need to then basically create. We basically just need to just create a new data, basically. Um, and we need to just repeat this process over and over and over and over again. Because isn't that what clustering is all about? Uh, Um, okay, so we don't actually need to do this. So we just need to create the new data again. And as we see, data is just a list of lists of all the. So this is the part where we need to repeat. So we've done made the first cluster, but this sort of mean clusters are basically because wait, let's just print clusters here. So so print, right? So it's the same thing that we have here in our new data. Let's see. Yeah. So it's the same thing we have, but now we need to just loop over it. Basically, so we've already created the clusters here, but now we need to just make this into a loop. Yeah. So that's basically what we need to do. Um, so a naive solution is to okay, so what parts do we actually need to loop? We need to loop the basically we create the clusters. We need to loop the part where we're assigning the points to the nearest clusters, right? Um, so we need to do for I in range 1,000. Let's just do 1,000, and we'll just add this in later. Um, yeah, right, and we just need to loop through doing this process. Uh, um, so okay, so this is what I did. I loop over, let's say, 1,000 iterations, and at the end of it, we just assign cluster. We rewrite cluster to be the new cluster. Um, and No, this won't work. This won't work for a couple of reasons. But look, we're calling so we're creating the mean clusters, right? And we're basically saying mean clusters of k is equal to v dot mean calls, right? That means for clusters dot items, it has to be a matrix. Let's look at what it is here. Uh, it's not a matrix, which is unfortunate. But yeah, it's just not a matrix. Um, so what we have to do is before we do this, we have to do new clusters. Uh, uh, yeah. Wait, let's just try running this, and we'll figure out the errors that happen. And I think that will be an error. And then we'll debug it, and we'll yeah. So list object has no attribute mean calls, right? So that's the first thing. So we have to do new clusters. We have to basically just convert it into a matrix, which isn't too tough because we have it in that form here. So we just copy this code, but instead we do it for new clusters. So we do for k.v in new clusters items. Well, uh, so let's try this out now. Wait, where am I multiplying? Euclidean distance. Uh, line 52 seems to be the thing. So, ooh, okay, so the dims don't match for multiplication. Oh, we need to prepend, okay, so we're calling here, we're calling remove call 0. Uh, wait, why are we calling remove call here? And that's of matrix. Whoa, 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 whoa. We're prepending on matrix.k. We're creating this, and then we're removing the call, which we shouldn't be removing it here. Why do we even need to remove call here? Why can't we remove call here? Am I tripping? Like, why do we need to remove call for in range 1,000? Like, And then like we can also just add a quick return new return clusters. I must be calling it somewhere. Yeah. Yep. So all right. So does this work? Um. No, no. There's some error here. Like look. Like it doesn't make sense. Wait. So let's do pr uh okay. So wait. Let's just do a normal for loop just to display the stuff. So we do for k copy um print k and then print and then oh, okay. Okay, so let's see it's clustered properly. There's two new lines for some reason, whatever. 2 and 3. Wow, it's clustered remarkably well. And let's just make sure. Quick check. 1, 2, 3, 4, 5. 1, 2, 3, 4, and it's reasonably well to interpret. Uh, me and you, your brother, and you are two. Me and you, your brother, and your mom, two. Back, da, 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 da. All right, it's working fine. Now let's just check what he said after that. This is working. Probably not the most efficient method. Euclidean distance, whatever, 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 whatever. Uh, but we don't actually need to check if do actually just like 1,000 things, but it's simple to just keep it 1,000. It's probably not necessary. Well, okay, actually we can add a quick check. So we can basically say uh if clusters is equal to new clusters, um then return clusters. And then also we can add a quick print um uh so let's just see that. But just to make sure that it should print 4 this time. Yep. Okay, so it's working. So it actually this is much more efficient. It only needs 2 times to just basically just get it k-means clustered. Uh, all right. Yeah. So we have it k-means clustered, yada yada yada. It works reasonably well. Maybe it's not the most efficient implementation, and I'm sure there's a lot of problems because we especially create so many extra arrays, matrices, lists, whatever, whatever. So that's probably a reason. That's probably something that could be improved with this type of implementation. Um, but it works. But it does work. So it does work. Did I? Yeah. With this time it doesn't even print I anymore because why would we want to print I? Okay. To choose k, right? Graph the cohesiveness of the clusters versus the value of k, computing the total sum of distances between points and their cluster centers. Okay, then generate. Well, okay, let's interpret the clusters. These are basically ones where if you look at this, this has like no. These have none of the first ingredient, which is eggs. These are basically egg-free vegan ones, basically. Um, these ones are like heavy on the egg. These ones are sort of a well spread out thing, but these are like vegan, basically, no eggs. They have butter, so I guess not really vegan, just eggless. Um, yeah, yeah, it's just eggless. Yo, it actually works. I'm really glad that this works. Like, I'm legitimately just glad that I finally got something working. At least we're not getting cooked, by not letting it work. Low-key, okay, fine. Let's just generate a total distance versus k, and then identify the elbow. The total distance, okay, so the total distance, so that's reasonably easy to so anytime we're going to return, right, we just need to get the total distance formula. So, so for, So this is like a efficient piece of code we can use. So basically loop over all the rows in the matrix, and we don't need this, and we don't need this. But what we do need is we need this right here. So total distance. Um, let's say it starts at 0, because I don't think Euclidean distance can be. Can Euclidean distance be less than 1? Whoa, that's exactly what I need to know. Non-negative value. Cool. Oh wait, to be fair though, it is Pythagorean theorem, which can't be negative for no matter what x value you plug in. Even if you plug in negative values, -1 squared, it's squared, so it won't be negative. Okay. Anyway, so basically just we find the distance and then we do total distance plus equal distance. And then return clusters, comma total distance. Comma. Oh, and then we have to recalculate it. It's fine. Let's just copy this code in anyway. So it's fine. Let's just like get a little bit lazy and let's just say output is equal to. Okay, I know this is getting a little bit lazy, but fine. And then basically say total distance equals output. Okay, so we'll just print the total distance and then let's just quickly add a label saying whatever. This was a really fun exercise, playing around with. What? There's no way this is right. There's just no way this is like this right. There's just no way. I mean, there's something that we've done wrong. Um, Oops. Yes. So that's a very funny error. Yeah. We're actually adding 0 to 0, and no matter how many times you add 0 to 0, it'll be 0, obviously. So just check that out. Yep. And this is now working rather wonderfully. We get the total distance. Um. So we should probably do some like matplotlib type visualization. Is that how we're supposed to do it? Okay, anyway, so generate a plot of total distance versus k. Is that it? Okay, that's it. So I guess we should just make sure that are we using a Venn? Pip install. Let's just make sure matplotlib is installed. Okay, we're good. So let's just do set an import matplotlib. I'm gonna do from matplotlib import matplotlib.pyplot as PLT. Or we could probably just do from matplotlib import pyplot as PLT. Okay, so now what we basically need to do is we need to do create an array of basically k values, so k vals. And then we need to basically say distances. right? And then basically we need to just go through. So let's just do uh for 1 to let's say, well, how many? What's the length of this thing? Uh, let's just do. Put in some random numbers for now, just so we get the exact number. 4. What? Oh no, we just do the len data. 19. Okay, so we have 19 data points. So we can do 1 to 20. Or, well, 1 through 19. Well, no, it's. If I do in range 10, it will be 0 through 9. So it's inclusive. It's not inclusive of the. Yeah, stop is exclusive. So 1 through 19. Okay? And the distances is this. So we just do uh 4K in K vals. What we can do is we can do k-means clustering. Uh, we can do k-means clustering of the data, and then we can do k k, or maybe we'll just do k vals, and then macerations, whatever. That doesn't really matter. It's already preset. So and then we do distances, and this dot one. So we need to make sure we don't get the actual k-means cluster. So we actually just need the distances. And then once we have the two distances, we just do plt dot plot. Is this how you do it? It's been a while since I've worked with. Oh, it's gonna. I need to do. Oh, I thought I had it working. Maybe I should have written some tests. Uh, um. Hmm. Hmm. That's kind of tough. Oh, wait. What we can do is we can. Um. The problem is here in line 61. So the problem is that this the problem is this isn't always gonna have the length. Wait. Uh, Then and then print else block. No, what we're gonna do is we just need to make sure our matrix class can handle this. Uh, if there's a index here, I need to make sure the matrix class can handle zero matrices, which it probably still can't. Line 89, dude. Okay, wait. Wait, what? Oh wait, I think I'm supposed to put the. Wait, what? Did I plot it right? It's supposed to be form an elbow graph. Dude, there's no way this is supposed to be right. I mean, there's just no way. Like, cause as you move on through the. Dude, like, the graph? Hmm. Oh. Oh. That's kind of ugly. So that's an error. We should find this error here too. That's an ugly error. That's a very ugly error. Let's check if that's what was causing it. No, what? It has an elbow, but the elbow is here and going that way, not down one. Okay, let's just see, make sure we read it correctly, right? So we basically just uh put in their cluster centers. Like the graph is still obviously upward, and it's just like, bro, what am I doing, dude? Oh. Ah, dude, we're adding all the distances. Of course. Dude, what am I doing here, brother? Ah, okay, so we need to basically just copy this code in. So, okay. So first of all, this code is, we need to copy this code in, right? We'll just do it for this one because this seems to be getting triggered reasonably often. So min dist is equal to float inf, right? So we just basically say if um if the distance is less than the minimum distance, then min dist min dist is equal to dist. And when do we add? We add here. Why there? No, we add there under the row. Oh wait, this should fix it. Does this fix it? Does this fix it? Am I cooking? I'm cooking. Wait, no, I'm not cooking. I'm not cooking, dude. I'm not cooking at all. The highest distance should not be at 3. It should be like, hmm. Okay. This is a little bit of progress, but why is the error still there? Like, I feel like we were onto something for a second, and then we were like checking it back, and we realized that like, no, we're not onto something. Okay, well, quickly, let's just indent that correctly. Let's just add this bit of code here. We need to make sure that this is implemented. Whatever. So some of them, maybe this is being triggered. Um. Hmm. No. Oh wait, you guys can't see the graph. Uh, okay. Yeah, you guys can see my whole screen for a second. Yeah, you guys can see this. Look, it looks like a volcano. Up, down. Not particularly fun. Especially because that's not how it should be. It shouldn't be up and then down. Mmm. Wait. We're cooking here. We're cooking here. Wait. Wait. Boom. And then, where is this? Boom. Wait. We might be cooking here. We might be cooking here. Wait. We cooked! Yes! Yes. Yes. It finally works. Oh, it works. Oh my god, it works. The code works. The code works. Yes. Elbow plot. Yes. Yes. Okay. Let's just do some quick testing now. So 7. Should throw an error, I believe. Yeah. Okay. Whoa, is there a second elbow? That's fascinating. Yes. Yes. Let's run it again. Oh wait, you guys can't see it. Yo, you guys need to view it too. Boom! Elbow right there at 3. Elbow right there at 3. Kind of like an elbow at 4 too, to be honest, bro. There's like 2 elbows. But let's compare it to the expected. Um, which is here, right? And yeah, it is basically the same graph. Oh, you want to do a thing comparison? Okay. Hopefully, you guys can see it. And pretty close, reasonably close. Now we're gonna go. Yeah, elbow the graph is near K plus 3. Tic tac toe and connect 4. We are done with this one. Maybe we should make our thing be able to able to handle negative zero length matrices. But that kind of just f's up our whole multiplication thing. Like I don't know how I was supposed to handle that. Because like how do you how do you compute the Euclidean distance? Ooh, I have an idea. So you know how the normal error was throwing, like let's say let's make it 10. The error is value error, right? And where's the value error? It's inside Euclidean distance, right? Um. So maybe we surround that in a try except block. Oh, but then that'll arbitrarily like. Yeah, but didn't we surround it in a try except block? Line 82. It's happening in line 82 in k-means clustering. All right, so we'll surround that in a try except as well. Well, technically, the mean of nothing has to be. I don't know what it would be, but let's just give a value error. this is equal to 0. Yeah, it looks fine until 5, but after 5, there's a really steep drop down. Because the distances are all empty, or I don't understand. Actually, let's just do k-means clustering here of data of 6, or let's do 7 or 6. 6 is a good number. Um, and then let's just do that. Yeah. 1, 2. But yeah, actually, why is the uh? Uh, apparently, if the what I'm doing is I'm making it 0, but if it's okay. So when k becomes too large, right? Some clusters end up empty after a reassignment step, but centroids for those clusters aren't really updated, so they get sort of abandoned. Hmm. Okay. Yeah, that makes sense. That makes a reasonable bit of sense. So, so how do we stop this? How do we stop this? I think the key place to stop this is inside our. Okay. Put some spaces first of all. Put some spaces. Put some spaces here. Like put some spaces throughout the whole code. And we need to. The main part is new clusters.items. Uh, is for k comma v. Right? So we just say that's equal to matrix V, but we need to make sure that if len V is equal to 0, then new clusters.k just give it a random number, bro. Oh my god, bro. Why? Okay, there. Yeah. Let's just quickly import random too, so we have this. Wait, let's just check if that fixes. This is like a hot fix I found on Stack Overflow, so this shouldn't particularly work. Never mind, it does work. It works perfectly. I don't know why it works, but it does work perfectly. It works like incredibly perfectly. Like, why does that even work? Whoa, 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 whoa. Why does that work? Stack Overflow says so. Okay, a cluster has no points, right? But normally we compute the means, assign each point to the nearest mean. If no points are closest to a particular centroid, that cluster ends up empty. That cluster ends up empty, right? But then you don't give that new empty cluster a um new centroid, right? So instead we should randomly assign it because yeah, because it still has that old very bad thing. So a random center, so it could potentially just happen to grab points in. Yeah, but this works. This works reasonably well. It's nice that you can sort of notice the elbow plot. Let's just run it. Bro, let's just run it like crazy. Yeah, this is nice. You can really see the elbow now. Let's run it. As you guys see, you can really see the elbow around 3. It goes boom, boom. So you can really see the elbow. Yeah, that might be it for today. But let's just read over the next thing we're gonna do. Whoa, this is a lot of code we've done, especially in this whole section. Like we've done so much coding. Especially so we could do tic-tac-toe connect 4 object level implementation. Yeah, we can basically just what are the exercises? Develop tic-tac-toe players with random players. Easy. That's really easy. We can just do this really quickly because we have a lot of experience with this. Strategy players. We could even maybe just do Minimax. Um, Custom strategy. Cool. We'll do that. Repeat the above exercise for the game of Connect 4. Euler estimation. We literally do this in math. Of course, where we know Euler estimator. Ooh, this is gonna be fun. Alright guys, boys, but I have to head out for today. Thank you guys for watching. Yeah, see you guys next video. And we'll be basically creating a basic tic-tac-toe game from scratch and Connect 4 games from scratch. And then we will be moving on to um making an Euler estimator, I suppose. And then let's just see what's next. Euler estimator and then SIR model. Boom, I guess. A Hodgkin-Huxley model. Whoa, this is getting a little bit complicated. We need to make sure to lock in on this. Parse it, read it. Yep,